In this video, we're going to keep solving trig functions. This is the second video in this mini-series, and we've broken it into two videos because solving trig functions and trig equations is quite hefty. Without a calculator, there's usually a lot of underpinning skills, such as understanding the domain, understanding the unit circle, exact value triangles, converting between degrees, radians, knowing whether your quadrants are positive or negative, etc. There's a lot of little skills in here, and this question is no different. So what we're going to do is we're going to solve this the quotation normal way, and then we're going to have a look at what the issue is. All right, 2 sine 2x, take 1 equals 0. So 2 sine of 2x equals 1. So sine of 2x equals 1 over 2. So then we need to think unit circle, so we would normally do, where is sine equal to a half? Well, at pi on 6 and at 5 pi on 6. So what that means is when your whole angle in here, this whole angle equals pi on 6 or 5 pi on 6, you get an answer of a half. So that means 2x is equal to pi on 6. So x is equal to pi on 12. That also means 2x is equal to 5 pi on 6. So x is equal to 5 pi on 12. Now normally we'd be thinking, yep, done. Easy peasy, smashed it. Well, what we just did is our first unit circle we drew was talking about this domain. So we drew where 2 pi, this 2x goes from 0 to 2 pi. We drew where this 2x has one full revolution all the way up to 2 pi. So what we need to actually be thinking, so I'm going to zoom in here a little bit and focus in on this bit. This is where the value of x is between 0 and 2 pi. Now, at the moment, if I think about where these answers sit, if I was to draw a second little unit circle of where these two would sit, pi on 12, well, that's just, God, that's down here somewhere, pi on 12. And then 5 pi on 12. 5 pi on 12 is less than 6 pi on 12. So it's like here somewhere. Now, if we think about that, that means there's probably another 2 solutions here, something over here and something over here. So we've got 2 solutions, but there's probably 4 solutions. So one way that we can go about this is to think about the orientation like that we just did on the unit circle here and have a bit of an estimate about where we think these values would be. However, the most elegant solution when you have a number inside your angle that is not just x like we had before when it's a 2x is to change out what your domain is. So what I mean by that is, what are the transformations that are happening to your angle? So in this case, my transformation on my angle is just times by 2. And what I'm going to do is I'm going to actually transform my domain. So my transformation of 2 is going to apply to my whole domain. So what that means is I'm actually going to be looking at 2 times 0 and 2 times 2 pi. Well, 2 times 0 is still 0, so that's good. Lucky maths for us. And now I'm going to be going up to 4 pi. So how do we fix our solution now? Well, what that means is, let's have a look back here now at our original circle. And now I'm going to change my pen to red. I was at pi on 6 and then 5 pi on 6. However, I can now do 2 revolutions. Instead of just going to 2 pi, I'm going to 4 pi. So that means I'm also going to be back here and back here. I'm going to be at the same angles again the second time I come around this circle. So what that means is I need to change these angles here. I can simply make a copy of these angles here, and all I'm going to do is just add a full revolution, because if you think about these two locations just here, they're both pi on 6, except one's the first pi on 6 and the other one has had a full revolution. Okay, same with this angle back here. This is 5 pi on 6, and then the red one is just the same place, just with another full revolution. So what that means is, yes, 2x is pi on 6, but that also means, I'll do it in red, sorry, but that also means that 2x is equal to 13 pi on 6. So all I did is I took this number and I added a full revolution, which is 2 pi, which is 12 pi on 6, and I added that. So that means that x is equal to 13 pi on 12. Let's do the same thing below. I've got 5 pi on 6, and I'm going to add a full revolution using the denomination of pi on 6. So 2x is equal to 17 pi on 12. So, sorry, that was silly of me. 17 pi on 6, which means x equals 17 pi on 12. So, really, it's not a heck different, and in fact, I think this transformation isn't going to be too difficult to grasp when it's a nice, simple B transformation, like we have in there, just a simple number times x, like you've made your angle twice as big, or you made your angle 3 times as big. I think it's definitely going to get trickier, though, with a question like B. So, with B, I'm going to write the question, then I'm going to do the transformation immediately to my domain before I go too far. Alright, let's move some stuff around, make that positive one. 2 pi take pi. Oh heavens. Alright, so B. Now I'm going to make sure I do the transformation on my angle before I do my unit circle and start solving. So 2x take pi, I'm going to move the 1 over. The next thing I'm going to do is move the 2 over, so 2x take pi equals a half. Now, we still do our circle like we did before, and we're going to be looking at where is cos a half, but my domain was negative pi to positive pi. So I'm going to do that over here. Negative pi to positive pi. Now, my transformation that I have done on this, if I zoom in over here in a different color, my transformation I'm looking at is times or multiply by 2 and subtract pi. Now, let's not overthink it. Think about our order of operations. We need to do the multiply before we do the subtract. So, I have negative pi times by 2, take away pi, less than, then I've got pi times by 2, take away pi. This looks more confusing than it is. Negative pi multiplied by 2, well, that is negative 2 pi, take away pi. 2 times pi is 2 pi, take away pi. Negative 2 pi, take away pi is negative 3 pi. And 2 pi take away pi is pi. So we've got 2 revolutions here, except one of them is negative, and it's negative for 1.5 spins. So if I look at that in a bit of yellow here, what that means is I go all the way around and back to here. That's negative 3 pi. The other one, if I was to look at that in green, just goes around here. So, using that logic, let's have a think about where is cos equal to a half. Well, bringing back some fundamentals of our unit circle again, cos is equal to a half when we are looking at pi on 3. Now, I'm going to do this in green because I'm thinking about positive angles up to a half. So pi on 3, 2 pi on 3. Then I need to be thinking the other way around. So we said before, I'm going to go backwards in yellow. I can go all the way around to here. Now I'm going to draw a yellow line here as well. So the yellow line is 4 pi on 3. And then I keep going around to here. And I am now at 5 pi on 3. Except these yellow angles have been going backwards, so they are negative. So we've got 4 answers, and we're going to do the yellow ones or the green ones first. We know that 2x take pi, again, our whole angle is equal to these things. 2x take pi equals pi on 3. 2x is equal to pi on 3 plus pi. Now, common denominators here. A full pi plus pi on 3 is 4 pi on 3. And now we're going to divide by 2, which is going to give us 2 pi on 3. The next one, 2x take pi is equal to 2 pi on 3. So 2x equals 2 pi on 3 plus pi. Common denominators. So what I mean by that is if I made that 3 pi on 3, okay, so I've got 5 pi on 3, and I'm going to divide it by 2, so 5 pi on 6. In yellow, the other angles here, 2x take pi equals negative 4 pi on 3. 2x equals negative 4 pi on 3 plus pi. 2x equals negative pi on 3. X equals negative pi on 6. And then lastly, I hope I've got some room here, 2x take pi equals negative 5 pi on 3. 2x equals negative 5 pi on 3 plus pi. 2x equals, what's that going to be, negative 2 pi on 3. And x equals negative pi on 3. Alright, so with questions like these, as we can see, and I'll do it again in some highlighter, when you are modifying the angle that is inside your trig function, sometimes it is far easier to just manipulate, like we saw over here, manipulate what your domain is. Okay, it ends up being a lot simpler because when you are indicating, same over here, when you're indicating your values on your unit circles, like we saw here, and like we saw down here on this unit circle, it is a lot easier, I believe, when you're going ahead and solving, and you're not going to end up forgetting or missing the other two solutions.